kind of kid who was turning over rocks, taking bark off logs, just mucking around. Don't know why.
And all the kids are really into bugs. I'm deliberately trying to avoid them being afraid of anything. So, you know, I have a fear of spiders, for example, that I've gotten almost rid of over the years. So I'm trying to make sure that you know, the kids don't learn to be afraid of it. Everything is interesting. You know, you don't touch bees, but you know, it's certainly, they're cute to look at.
There was one thing I was absolutely never ever going to do in my entire life, and that was genetics. I loathed genetics as an undergraduate student. You know, it's what nearly always happens. I met a truly inspirational person. I met the geneticist Antonio Garcia Bellido, who literally changed my life. He convinced me that the only really effective way to understand how nature works was to be a geneticist. Many people of his era had a mantra which was, "You don't know the answer, ask the fly." And the idea was that genetics allows you to create conditions in which the organism will answer the questions for you.
I guess by fly you mean Drosophila?
Yes. My wife is an entomologist, and I annoy her no end by talking about the fly. She keeps saying, "Hugh, there's 50,000 species of flies," but for me, there's only one fly.
Biology is always changing, and there's always something new, something being discovered, something changing.
High school, basically, a inspired biology teacher in grade 10 who sort of really made biology and exciting.
This gene I studied for all those years turns out to be the most highly mutated gene in most kinds of leukemia. And so, to me, it's a brilliant argument for the importance of basic science. I was studying this particular gene just because I found it interesting. Completely astoundingly to me, it turned out to have direct application to one of the most important human diseases. I just think that's so exciting.
Most of my work right now is on HIV, and I think what excites me most is, again, just here we're looking at like specifically a virus, and a virus that is able to mutate like this virus does. That in itself adds another whole dimension of complexity, because you design something for a certain genotype of the virus, and then the genotype will change or it'll mutate. So you have to be always thinking ahead or always planning ahead, that you can't just put yourself in this box and remain there, because it's going to keep changing, so you have to as well. And then what happens is the drugs change, so then the drugs change the dynamics too, and things like that too. So there's a lot of influences that all come together.
My professors at the time were people like Michael Smith and Julia Levy and Bob Hancock, you know, all people who were not only rising stars but stars at that time, and you know, you could actually see that, hey, you know, there are potential Nobel laureates amongst the people that you're working with, and that can be pretty exciting.
It's okay to change your mind and be wrong. Some of the unhappiest people I know are doing stuff because their mom wanted them to be a doctor, they could make a lot of money being a stockbroker, whatever. The cool thing is that when you get it right, you're doing something you love, and that's the secret. If you don't love it, don't do it.
You can work in biotechnology and be a lawyer, and you know, deal with patents, intellectual property protection, business contracts, financing contracts. You can be an accountant, you can be a communications person, you can be a business person. You can be almost anything that you want and still work in the science industry.
I wasn't sure personally how I would do dealing with patients, but I wanted to be in the science part of things. So I figured if I continued with what I was doing, I'd be still helping patients, but I'd be behind the scene, and I could sort of be useful in that setting. And
So you're part of the system, but you don't have to give anybody bad news.
That's right, exactly. Hopefully give them good news.
Yeah.
As with most kids, when they started in biology, medicine was a possibility. But once I got into research, it was much more fun, much more interesting to try and understand what was going on behind diseases rather than necessarily treating them.
Different strains of flu viruses mix in chickens and pigs, and they swap genes and become something brand new, which our body hasn't experienced. That's why you have to get a new flu shot every year. The old one isn't effective within a few months after being produced. If you're being exposed to antigens all the time, your body's fighting them off and you're not even aware of it. It's only the sick that you're aware of. And so having a vaccination is simply, speeding up the process. You're basically getting exposed to an antigen to protect you from a disease you haven't encountered yet. And, I even had to correct my wife on that. She was falling into the anti-vax craze. And fortunately, though, one of her best friends is a doctor, and she was on my side.
I think in practice, geneticists are the author of their own misfortune. They say, we have found one gene, and if we understand how it works, we will understand cancer or schizophrenia or Alzheimer's. Most of these complex problems have complex origins. And it's surprising, even shocking, how few medical treatments have arisen from knowing a great deal about the molecular biology of a given gene. So for example, the gene responsible for essentially all cases of muscular dystrophy has been cloned for nearly 25 years. Do we have a cure for muscular dystrophy? No way. The biology just turned out to be so much more complex than we imagined or could imagine. We're only just beginning to scratch the surface. Genetics is at the stage physics was at post-Einstein, so 100 years ago. We're starting to see the possibilities. We're starting to understand just how complex the problems are, but in real life, all the interesting stuff we don't even know is out there yet. I think we're reaching the era of what you might call high throughput biology, where you are gathering enormous data sets, and that takes a team-based approach. So there's a lot to do, but I think people's vision of a mad scientist working in obscurity in a dusty place is completely wrong. The new science is team-based science, cooperative science, international science.
Canada has lots of opportunities. I mean, we have great universities. The funding is not bad. The scientific world is global. Your collaborators, your connections will be anywhere in the world. Canada is highly recognized as being a great place.
I think the biggest surprise is the actual change in the industry. You can be in certain jobs, and it can be the same job year after year, day after day. But with this industry, there's always new discoveries, and then when there's new discoveries, there's new technologies, and when there's new technologies, there's new instruments. So I didn't stop learning when I got out of school.
So the take-home message is there are good careers in science. Stick it out. I mean, you can do all sorts of things once you've got that basic science. You never know where you're going to wind up, and that's the important thing, is to keep an open mind. But there are certain core things, core scientific training, basic science, that you need in order to help you make those kinds of decisions.